All right, stats. Welcome to your Chapter 11 quiz review video. We did several questions in class yesterday. Here are the answers to the ones we didn't. Number 3, the lengths of pregnancies are normally distributed with a mean of 266 days and a standard deviation of 16 days. What's the probability a randomly chosen woman will have a pregnancy that lasts longer than? This is just one randomly chosen woman. So if x equals pregnancy length, this is just the probability x is greater than 285, so we just use that formula right there. Z is x minus the mean divided by the standard deviation. Get that z-score 1.19. The area associated with that z-score is 8830 because it's a greater than, you subtract it from 1. B is different because I want the average to be less than 262, so it's a probability x bar is less than 262. So that's where I got to do 16 divided by the square root of 75. Always round that standard error, that's what that's called, standard error, to 3 decimal places so you can get your z-score as accurate as possible. Negative 2.16 is the z-score. That's the associated area. Because I want less than, I do want to keep that area. Next one, 144 women are randomly selected. Okay. X bar, we want to be 272 minus 266. We do 16 divided by the square root of 144. That is 1.3 repeating. That z-score is 4.50. You're going to get some big z-scores. All right, either in the positive or negative direction. Anyway, the area associated with that is straight nines, we'll call it. Want to be greater than that, so 1 minus 4 nines is 0.0001. 200 women are randomly selected. Find the probability that their lengths of pregnancies have a mean that is no more than, that is wrong. No more than is less, I didn't even read that. Wait, I'm not reading correctly. Is more than. Yep, so I was correct there. It is greater than 270. That's funny. That is more than 270. All right, so we're going to keep that greater than. Anyway, there it is. 16 divided by the square root of 200 is 1.131. Divide, you get that. And z-score, the area associated with that z-score is straight nines. More than, you just do 1 minus straight nines. Okay, sorry for that little boo-boo there. Next one here, number 3. Talking about battery length. So exciting. What's the probability of randomly selected battery? So just a single one. That's when you just use x. Again, x is battery life. So you do z equals 65 minus 60 divided by 8. Z-score is 0.63. The area associated with that is 0.7357. Again, pause this whenever you need to because I want to be greater than. I do 1 minus that. Now we have 150 batteries that are selected. What's the probability that the mean lengths of their lives is more than 56? So I want to know the probability that x bar is greater than 56. It should be a great probability, a great chance. If the mean life is 60 months, I want 150 of them. What's the probability that the average of 150 is better than, way below average? I mean, it's about 1. 56 minus 60, 8 divided by the square root of 50. All right, you get negative 6.13. That is off the z chart, so just call it 0.0001. I want to be better than that. I want to be greater than, so 1 minus that. All right. 300 batteries are now selected. What's the probability the mean lengths of their lives is less than 58? Probability x bar is less than 58. We would expect this to be low. All right, big sample. I want them to perform, 2 months below average. On average, get a very small z-score there. 0.001 is the area associated with that, and because it's less than, we keep that. If 100 batteries are randomly selected, find the probability that the mean lengths of their lives is less than 57 months. Probability x bar is less than 57. All right, so that's the z-score. We're going to use 0.001 again, and we're going to keep that. All right. Moving on here, we did do all 4 yesterday. I just want to do it again. Anytime it says sampling distribution, did forget the x bar, x bar, x bar. X bar is approximately normal with the same mean, and its standard error is the standard deviation divided by the square root of n. All right, so 12 divided by the square root of n gives you 1.2. It's approximately normal, mean of 86, standard deviation of 1.2. That's sampling distribution of the mean. All right, next page, the Chevy Cobalt's question. What's the probability randomly selected cobalt gets more than that, so that's just press probability x is greater than 34.5. Don't do anything with a sample size there. 0.40 is the z-score. The area associated with that is 6554. I want to be greater than, so I got to do 1 minus that for my answer. Now I do have a sample size, so what's the probability that it exceeds? Exceeds is greater than. Probability the mean is greater than 32.5. All right. 2.5 divided by square root of 50. Your standard error is 0.354. Get a negative z-score, negative 2.82. Area associated with that is 004 or 24. Then 1 minus 0024. Again, what's the probability that the mean of 50 of these cars is going to be better than a below average, miles per gallon? It's going to be pretty high there. 125 is now the sample size. 31 minus 33.5 divided by 2.5 divided by square root of 125. Wow, that's a tremendously low z-score. 0.0001. What's the probability that 125 will have an average that is well below what it should? It's almost impossible. All right. We did 7A and B yesterday, so here is 7C. What's the probability 125 randomly selected adults have a mean IQ score of more than 105? So that's the probability x bar is greater than 105. All right, 3.83, triple nines, or, 4 nines. 1 minus 9999 is 0.0001. You're going to see a lot of that. You're going to have a lot of 9999s and 0.0001s. What's the probability 300 randomly selected adults have an IQ score of less than 97? Okay, this one is actually on the Z table there, and it's that. What's the probability that 25? We can do 25. 25 is less than 30 because we can do this because IQ scores do follow a normal distribution. All right, so normally it's got to be greater than 30 if we don't see that. 30 or more, that is. That's a z-score. So I want greater than, so I got to do 1 minus that. All right. Let's do number 8 real quick. Just got a few more I want to do. If you choose one student at random, what's the probability they are between 68 and 72 inches tall? This is just one randomly chosen male. So find your 2 z-scores there. There's the area associated with both. And then I want in between, so I just subtract. Measure 25 students. What's the sampling distribution? Again, I can do 25. It is less than 30. But the male heights are approximately normal. Okay. So the sampling distribution is that. You need to write your answer like that. Now we're going to use that for the rest of that, because you do have a sample of 25 students for all of these. So probability the mean height is between 69.5 70 inches. There it is. There's this area associated with both. They are complements. So just subtract. What's probability the mean height of your sample is more than 72 inches? Probability x bar is greater than 72. So 1 minus 4 nines. What's probability the mean height of your sample is less than 69.5 inches? Less than, I keep it. Okay, you can pause this whenever you need to. And the last page here, again, you have the same page printed several times, sorry about that. To figure out what x bar is in all these, you need to do 355, in this case divided by 40, because you have 40 jets, so you need to figure out what x bar is. Okay, what's the probability that x bar is less than 8.88? All right, 2.5 divided by square root of 40. You get 0.96. The area associated with that is 8315. I want to be less than, so I keep that 8315. There's probability that it's going to be more than 330 minutes, or that x bar is greater than 330 divided by 40, 8.25. There it is. Sample size is still 40. So really, I could have just used this as well. I didn't really need to write 2.5 divided by the square root of 40. All right, so we get that, and I want to be more than, so I do 1 minus that. What's the probability it's between 330 and 355? Well, I just did that. What's the probability x bar is between 8.25 and 8.88? Now be careful. I got to use the actual area associated with those z-scores. So I got to use this and this. I made initial boo-boo there. Anyway, get 5672. A produce company claims the mean weights has that. You see nothing with standard, or you see nothing with the words normal distribution. So you got to make sure your sample size is large enough. 250 is definitely large enough. So what's the probability x bar is less than or equal to 8.2? All right, there we go. That's your z-score, the area associated with it. So it's 0043. What's the probability a random sample will have a mean weight of 8.5 or more? So probability x bar is greater than or equal to 8.5. There's your z-score. There's the area associated with your z-score. More than, you got to subtract it from 1. All right, folks, this is your quiz review video for your quiz tomorrow. This is Yak Math Video signing out.